Okay, we're going to talk about 1.4 solving absolute value equations. The first thing we need to know is what absolute value actually means. Okay, and so in math we have quick and easy ways of writing things out. So one way to write out a sentence like a number that has a distance 4 units from 0, rather than writing that out by hand every time, what we do is we write it out as an absolute value. And using those symbols right there, these symbols mean absolute value, and absolute value actually means how far away from 0 whatever is in here is. So if we say a number, which we'll call x, so a number that is 4 units from 0, we just say we want absolute value of x to be equal to 4. Okay, and so on a number line, really we have two numbers that are 4 units from 0. The two numbers that are 4 units from 0 are 4 and -4. So this actually, most absolute value equations have two solutions. One's called a negative case. In this case, the negative case would be x equals -4. And one is called the positive case. And in this case, the positive case is x equals +4. And so really, when we do this, we just rewrite the equation. We drop these symbols, put x, and then we put a negative in front of the 4 and a positive in front of the 4. And notice when we actually put the positive in front of the 4, we're not really changing anything. We don't show a positive symbol. Okay? So the two numbers that are 4 units from 0 on a number line are 4 and -4. All right. So knowing that information, we're going to actually show the positive and negative cases here. So in this case, notice if we look at the equation, the absolute value is all by itself over here. So in other words, what I like to say is, like, pretend it's a house, and is there anything inside the house or outside of the house on this side? And there's nothing outside of the house. So we just say, hey, the absolute value is by itself. In fact, even if we didn't know what was inside there, we could say, well, absolute value is equal to 8. That means on a number line, I want two numbers that are 8 units from 0, which would happen to be 8 and -8, meaning that whatever is in here, x plus 2, which is what we know is inside there, right? Because we'll erase that, get rid of the house here, okay? That x plus 2 that is inside there, that x plus 2 is going to equal our negative case, which is -8. We just drop a negative sign in front of that 8. And then the positive case would say x plus 2 is equal to +8. And so we could show a positive sign. It wouldn't really mean anything there, but anything different. So in this case, what we'd do is we'd actually subtract 2 from each side and solve this. Now, if you actually wanted to show that on a number line, really what you're doing is saying -8 minus 2, you're actually going back 2 spots. So you're at -10. Okay, so x is equal to -10. And here, you're subtracting 2 and subtracting 2, which, once again, you're going back 2 spots. So in this case, x is equal to 6. We finish it up. And usually how we write that is x is equal to the set of -10 and 6. It's just a different notation called set notation. You use that when you have multiple answers. Some teachers will be fine if you just write x equals -10 and x equals 6. That would be fine as well. So here I'm not going to draw the number line this time. I'm just going to do my positive and negative case. Notice, I look at it, think of my house again, kind of a different looking house this time, but there's nothing outside of the house, right, on this side. So we're good to go to solve it. Since there's nothing outside of the house, we can actually set up our cases. So our negative case would say x minus 2, what's inside the house, is equal to, we drop that negative in front of the 4, so -4. And our positive case would say x minus 2 is equal to, and we drop that positive in front of the 4. And once again, that really doesn't do anything. I'm just showing it's the positive case. Here it really does though, right? So to solve, we add 2 to both sides. We get x is equal to -2. And here we add 2 to both sides, and we get x is equal to 6. Now you can check these. If I put -2 in here, well, -2 minus 2, so I put that in for x. Okay, -2 minus 2 is -4, and the absolute value or distance from 0 of -4 is 4, and that's what it says it equals. So we're good. And if I try out 6, well, 6 minus 2 is 4. And the absolute value of 4 is also 4. So 4 equals 4. So both work, negative 2 and 6. Okay, and we could write it in set notation, parenthesis, pointer or less than symbol, and parenthesis. So negative 2, comma, parenthesis, greater than symbol, parenthesis, 6. So two solutions, negative 2, 6. And if we kind of clean that up there, just so we make it try to look a little neater, try to make these look a little neater, negative 2 and 6. Okay? All right. Let's try some other stuff. Let's say we have some special cases here. So we know that absolute value, this means distance from 0. So we're trying to find two numbers, like there's nothing outside the house, right? So we're trying to find two numbers that are a negative distance from 0, negative 4 units from 0. Well, think of it this way. Like if I told you to go out and run a mile around the track, if you ran that backwards, you wouldn't actually run a negative mile. You'd still go a mile. Okay, it's just, it might be a little tougher and you kind of look weird doing it, but you're going backwards. Okay, so really there's no such thing as a negative distance. Whenever you see your absolute value, in this case it says our absolute value is equal to negative 4. Our absolute value symbols, there's nothing outside them, so absolute value is equal to a negative. That means it's a no solution. You can't do that. So we call that a no solution, and we'll just write no sol there. The other special case we see a lot of times is saying, well, our absolute value is equal to 0. So thinking of it that way, that really says, well, if x plus 2, the absolute value of x plus 2 equals 0, when I do my positive and negative case, well, the negative case usually we just say x plus 2 is equal to, and we drop a negative symbol in front of our number. Well, there's no such thing as negative 0. Okay, now if we do our positive case, we'd have x plus 2 is equal to positive 0. Also, no such thing as positive 0. There's just 0. So none of those work. Really, the only thing we do is just say x plus 2 equals 0. So in other words, what number is 0 units away from 0? Well, if we subtract 2 on each side, in this case, well, we get x equals negative 2. Now, remember, that would say, like if we were saying absolute value of x is equal to 0, that's saying what number is 0 units from 0. This one's actually saying what number plus 2 is 0 units from 0. Well, if I'm at negative 2 on a number line, and I add 2 to it, that puts me at 0. So negative 2 plus 2 is 0 units from 0 because it's actually at 0. So whenever you have 0 right here, really what that means is you're going to have one solution when you're done. Whereas in all of our other problems, with the exception of the no solution here, we've had multiple solutions, 2 solutions. Okay? So those are our special cases, 2 of the special cases. Now in this one, we're going to do the getting the absolute value alone on one side. So notice here, like once again, if I keep going back to my house, okay, I look at my house and, dude, there's stuff outside my house, okay? There's other things outside the house. There are intruders outside of the house, if you want to think of it that way, kind of a creepy way to think of it, but there's stuff outside the house, and we've got to move that stuff away from our house, like clean up your yard, as one of my teacher friends, Mr. Dvorak, would say. Okay, so what we're going to do is we're going to subtract this 5. We end up with 2 times our absolute value is equal to 16. And remember, inside that absolute value that I've kind of hidden there is x minus 3. But you have 2 of those. You have 2 of those absolute values of x minus 3. And so they're multiplying, so to get rid of that 2, we're going to divide by 2 on both sides. So we get x minus 3. Absolute value of that is equal to 8. Now notice your absolute value is alone, or your house is good to go. There's nothing outside it anymore, okay? And so I'm going to stop using that house analogy here soon, but really, that just means I can start my cases. So my negative case, x minus 3 is equal to 8, and then we'll throw the negative in front of it. In the positive case, x minus 3 is equal to positive 8. And I'm not going to put the positive in there anymore because I assume you know it's not going to do anything. So there's our positive, our negative. Show our work, add 3 and add 3. We get x is equal to negative 5. And here, add 3, x is equal to 11. And just quickly checking my work, when I put negative 3 or negative 5 in, negative 5 minus 3, that's negative 8. Absolute value of negative 8 is 8 times 2 is 16 plus 5 is 21. So that worked out. And if I throw my 11 in, well, 11 minus 3 is 8. Once again, times 2 plus 5, 21. So we're good there. Negative 5 and 11. They both work out. Now, you notice I keep saying they both work out, and I'm checking them, because eventually we get these things called extraneous solutions that are going to come up. But before we get to those, we're going to solve absolute values with absolute values on both sides. So when you have something like this, notice on each side you have an absolute value. Whenever you have that situation, really what you're going to do is you're going to take and you're going to do your cases right away. You're going to say, okay, my negative case, I'm going to take and say whatever is in there, x plus 6. Notice I don't use my absolute value signs. I'm just saying what's in this, x plus 6 in parentheses, is equal to this thing in parentheses. And this is a negative case, so I'm going to always drop my negative sign onto that right side of the equation. So notice the parentheses are going to make a big difference there, because when I go to solve this negative case, first thing I have to do is distribute that. So I get x plus 6 on this side and negative 2x plus 3. Okay, and my positive case, really nothing changes, but I'm going to still show my parentheses, x plus 6 and 2x plus 3. Notice the positive, nothing happens there. So I could just drop the parentheses and write it like that. Okay, so I'm going to go back and solve this one. I'm going to go ahead and subtract x over. Okay, I end up with negative 3x plus 3 equals 6. All right, subtract my 3 over. I get 3 equals negative 3. X, and then divide by negative 3, I get x equals negative 1. One of my solutions. And then here, I'm going to go ahead and subtract x over. I get x plus 3 equals 6, and then I'll subtract my 3 over. I get x equals 3. And I'm going to test them. I put 3 in, 3 plus 6 is 9. Absolute value of 9 is 9. Okay, and 2 times 3 is 6, minus 3 is 3. Uh-oh, well, what happened there? Better double check my work, because something is not right on that one. Oh, I see what I did, and that's why we check our answers. That should have been a minus, which completely messes up a bunch of stuff here. Let's fix that up. Good thing we checked it. Not planned there, but hey, that's why we check our work. Should have been a minus there, which makes this a plus, which makes this a 9. There we go. So we put our 9 in. That's 15. Absolute value of 15 is 15. 2 times 9 is 18, minus 3 is 15. Negative 1 in. Negative 1 plus 6 is 5, and the absolute value of 5 is 5. And negative 2 minus 3 is negative 5, and the absolute value of negative 5 is 5. So there are solutions. X equals negative 1 and 9. And you notice my squiggly lines, eventually my brackets become kind of ugly. All right, now if you have a situation like this one here, still going to do your negative case, but you're going to put that 2, and you have your parentheses here. So 3x plus 5 equals, and our x plus 4. Okay, and we'll drop that negative in. All right, so we get 6x plus 10 distributing, equals negative x minus 4, distributing. All right, we'll go ahead and add our x over this time. 7x plus 10 equals negative 4. And then subtract our 10 over. Okay, we get 7x equals negative 14. And divide by 7. X is negative 2. Okay, and we do our negative case, or our positive case, which means nothing really changes at all. So we have 2 times 3x plus 5 equals x plus 4. All right, so we get distributing 6x plus 10 equals x plus 4. Subtract our x over. We get 4 equals 5x plus 10. Subtract our 10. Going to be a bit uglier answer. 5x equals negative 6. And divide by 5. X equals negative 6/5, also known as x equals negative 1.2. All right. Now, plugging our negative 2 in, that's negative 6 plus 5, or negative 1 times negative 2 times 2. Sorry, the absolute value of negative 1, which is 1 times 2. So we get 2. And then negative 2 plus 4 is 2. The absolute value of 2 is 2. So 2 equals 2. This one's good. And then we'll negative 1.2 in. It gets a little tougher, but 3 times essentially 12, if you think of it that way, is 36. So 3 times 1.2, or negative 1.2, is negative 3.6 plus 5. Well, negative 3.6 plus 5. When I do that, I get negative, we have 1.4 there, and then 2, negative 1.4, or excuse me, positive 1.4. And the absolute value of 1.4 is 1.4. Doubled is 2.8. So we get 2.8 on this side is equal to negative 1.2 plus 4. Well, that actually gives me 2.8, and the absolute value of 2.8 is 2.8. Works out. Okay, so both of these work. And I'm not going to write it in set notation this time. We're just going to leave it like that. So that's variables on both sides. This video is coming a little longer than I wanted, but hey, we're trying to get through all the different things. Extraneous solutions. Extraneous, the first 5 letters are, it says extra. That means there's extra solutions, ones that don't work. And so if we start this by doing our negative case again, notice there's nothing outside of the absolute value on this side. We'd have negative 2x plus 12 is equal to, and we'll drop a negative sign in front of this 4x. Okay, and then our positive case, we'd have negative 2x plus 12, just whatever's in here, just like we had here, okay, is equal to positive 4x, whatever's on this side. Okay, so thinking of it that way again, those are the pieces. We just drop the negative in here. We have the positive out here. So in this equation, really this just becomes negative 4x over here equals negative 2x plus 12. And solving it, we'll add the 2x over. Collect our variables all on one side. We get 12 equals negative 2x. Divide by negative 2. We get x equals negative 6. And here, we're going to go ahead and negative 2x plus 12, the parentheses don't do anything here, equals 4x. Add the 2x over. We get 12 equals 6x. So x is 2. Divide by 6, right? Okay. So in this case, I'm looking at these different answers. Plug negative 6 in. Negative 2 times negative 6, positive 12 plus 12 is 24. Absolute value of 24 is 24. Okay, we plug negative 6 in on this side. 4 times negative 6 is negative 24. No absolute value symbols over there. So what we're saying is 24 equals negative 24, which is not true. the not equal sign, this is extraneous. It doesn't work. We cross it out, we don't use it. We try the 2. Plug the 2 in. Negative 2 times 2 is negative 4 plus 12 is 8. Absolute value of 8 is 8, and 4 times 2 is also 8. 8 does equal 8. We're good there. This one works. This is a true solution. So this equation only has one solution, and it's x equals 2. The other one, the negative 6, was extraneous, so we don't include it. The other way you might see extraneous solutions are something like this, where you have a negative case, where you have, say, on this side you have x minus 5, okay, and that is equal to the x plus 3. Okay, and then if we look at our positive case side, really it's x minus 5 is equal to x plus 3. So you notice on the negative case I forgot something, and I forgot to drop that negative symbol right in there. So make sure we do that, yeah, for sure. So it should be x minus 5 is equal to, and we'll distribute that negative x minus 3. So don't forget that negative symbol there. In fact, I don't want anyone to miss that, so I'm going to kind of try to clean that up just a bit. That's a huge miss if I do that. So we're going to drop that negative symbol right there, okay? We'll distribute it around. And here, nothing to distribute, so you just get x minus 5 equals x plus 3. Okay, well, in this equation, it's fine. We'll go ahead and add x. Add x, we get 2x minus 5 equals negative 3. Add 5, we get 2x equals 2 divided by 2, x equals 1. Okay? And then here, let's test that one. We'll put the 1 in. 1 minus 5 is negative 4. Absolute value of negative 4 is 4. And 1 plus 3 is 4. Absolute value of 4 is 4. We're good. This one works. Well, here we try to solve. First thing we do, subtract x over, 0, 0. You end up with negative 5 equals 3. Variable's gone. This is not a true statement. So this is not going to work. So really, you just have x equals 1. That's the only answer that worked. All right. So one last thing, and it's a story problem. Your game club is having a party where each person buys a gift for another randomly chosen member. The maximum amount of money you can spend on the gift is $50. The minimum is $20. Okay, so I'm going to draw a number line here. I have 20 and I have 50. All right, that's how much I can spend. That's my range. Okay, write an absolute value equation that represents the minimum and maximum amounts that can be spent. These are really difficult until you realize the actual format you put them in. And really what's important to know is your range here. And halfway between 20 and 50, well, this is a range of $30. So halfway between 30, half of 30 is 15. So the halfway point would be 15 units this way and 15 units this way, right? And so that is our halfway point. Well, 15 units is 35, and then 15 units is 50. So we're good. So our halfway point, our midway point is 35. And so really, when you're setting these up, the equation here is x and our middle number, 35, is equal to this 15. Okay, in this situation. So if you were to check it, if you were to solve this, you should get 20 and 50 out as your answers. So if I do my negative case, I get x minus 35 equals negative 15. Okay, and when I'd solve, I'd add 35 over, and I'd get x equals 20. And my positive case would say, well, x minus 35 equals 15. And I'd add 35 over, and I get x equals 50. So it works out, okay? That's what I want. But the format you're using, notice this is my middle number. And this is the distance from your max and min to the middle. I'm just going to say distanced to middle. So if you're kind of writing a plan of attack on these types of problems, one way to do it is just to say this: x minus middle number, absolute value of that, is equal to the distance to / from middle number. Before we called that a hashtag, it was a number sign. Okay, middle number. Okay, if you really want to tweet about it and hashtag it, you can. Okay, but there we go. All right, and if you have an example like this, you can kind of describe it. Hey, middle number, these are your middle numbers, right? This is my distance from the middle, and you can kind of show where it goes in. I know a lot of arrows there, and it kind of makes it look a little weird, but you can do it in your notes, so it'll help you out. All right, hope that helped. Sorry it was so long, but we kind of covered everything that I can think of there.